Hello. Today we are going to code our Arduino with a sketch that requires referencing a library. On our today's assignment, there is a link to my code or Arduino's code that if you click on it will take you to the code that you could copy and paste into Tinkercad. What I'm going to do is add this to my sketchbook. It will open up this code in the online Arduino editor so that I can upload it to my Arduino. And so when that is copied over, it comes over with a picture, some extra tabs, and a picture of how I could build this on a Arduino, a circuit diagram, and some text that describes the materials you would need, the components you would need to put this together, and a little bit about the code, which is described in more detail here. And so this code is also available on the online Arduino editor by going to libraries. A library is a long list of definitions. And so for our Servo library, we're going to be using a long list of definitions that pertain to running this motor. I can scroll all the way down to S and find it. There it is, Servo, and drop down the two examples, knob and sweep. You can also search in libraries there, and we will be using sweep in a bit. But there's another link from the classroom for that. So in this code, it tells us to include the servo library, which is important because it's going to refer to that to know how to make its motions. Other libraries that you may use to run your Arduino to some fun stuff are the tone melody library that defines notes, or the liquid crystal display library that defines characters on a display for writing. This right here defines the servo motor. And then here we're going to put a potentiometer on there on analog pin 0. And this tells the Arduino that it is going to read the value of that potentiometer. This is the knob with 3 leads on it that we used before to run our motor or speaker. And then here it says that we're going to put that servo on pin 9 on the Arduino. Down here we have the loop that occurs over and over and over again, which tells the Arduino to read the potentiometer and then take that value, which goes from 0 to 1023, that's just the way the potentiometer was made, and scale it to a value that goes between 0 and 180 because that's the way the servo motor was made. And then go ahead and make that value happen on the servo motor, delaying 15 seconds to give the servo time to get there. 15 milliseconds. And that's just enough time to let the servo motor get there. We could modify this, but it's pretty optimized for a really nice smooth action where when you turn the potentiometer, you'll see those same actions reflected in the servo motor so that it works kind of like a joystick or a controller. So the next thing we want to do is build this on the breadboard. There is a nice diagram here that shows the components, the servo motor, the potentiometer, and the Arduino. The servo motor is in your kit inside of its own bag. There's many motors in there, but the servo motor is the one that has a brown, red, orange leads on it. Just 3 leads, brown, red, and orange. And the colors need to be followed according to this diagram, where that orange one, which is yellow here, goes to pin 9 on the Arduino. The brown one, which is black here, will go to the ground, and the reddish, dark, like umber lead will go to the 5-volt power. And one of the problems with this diagram is that it shows 2 leads going into the 5-volt power, but the Arduino only has 1 spot there. It also shows these leads connecting to the potentiometer like you would solder them on. But we have breadboard leads and they don't just hang out there like that. So we have to build this on the breadboard. So if we go back to the class, there is a copy, there is a link there to a Tinkercad circuit that I made. And I made it to look like how you could actually build this on the breadboard, where you put the potentiometer in the breadboard and make those connections by using those connections within the breadboard. How each row here, all of those positions in each row are connected underneath. So that gives you a way to connect those leads to the potentiometer. It also allows you to take the 5-volt and take a jumper cable and take it to that positive power bar so that you can get both the potentiometer and the servo into the 5-volt power. You could also do that on a row in the interior of the breadboard, but I went ahead and used the positive power bar for what it's labeled for. So this right here, if you build this as such, will allow you to run that code and upload it to the Arduino and get it to work. I'm going to show the code here. If you were doing this in Tinkercad, you would need, like if you didn't have the kit and you were doing this 100% in Tinkercad, you need to pretty much build this and do everything that's required if you have the kit in Tinkercad, but take extra screenshots of your work in progress. And so part of that is showing the code. So click here so that the code shows when you take your screenshots. And so if I start the simulation, we'll see if it works now, but before it wasn't working where I wasn't able to move the potentiometer. So it doesn't really work. And that's just because I can't, it's the potentiometer isn't working. You should, when it's simulating, be able to turn the knob on the potentiometer, but it won't let me do it. So it will work in real life. The next thing that we are going to do is upload a different sketch to this exact same circuit that we made. And this is the sketch called Sweep. It is in the classroom attached here as the second sketch. So if you click on that, it will take you to the code. You could copy and paste the code into Tinkercad. Control C on my PC. Control V. And let me just simulate that because this one works because it doesn't involve the potentiometer. If you look at the sketch, I don't know if that's going to have a picture or not. It does. Good. It's got the tabs there. If you look at the sketch of it, the example of it, there's no potentiometer on there, but since the servo is plugged into pin 9, what we have built here totally works. Don't take out your potentiometer. Just upload the new code, and it's pretty much ignoring the potentiometer and just sending out the code to the electrical impulses into pin 9, which is causing this guy to oscillate back and forth between position 0 and position 180, as described in the code here. I do want to see you modify this. If you upload it to an Arduino, then you can take a video, which I'll show you an example at the end, that will be evidence of your knob sketch and servo sketch successfully uploaded to this circuit built in real life. But if you're doing this all in Tinkercad, you would just have this page open and show me the modified code along with the other screenshots showing that you built this. So one way to modify this code is you could define the starting position differently, but I don't have it attached to anything, so it doesn't seem to matter where it starts. I wanted to go 90 degrees instead of 180. And so I changed this is for it moving forward, and this is for it sweeping backwards. So you have to change them both or else it won't be in the position it needs to be in to start the next part of that loop. But so now it should just go 90 degrees instead of 180. You can also change the delay. If I change it to 5, stop sim. If I change this delay to 5, it will go 3 times faster, but I'm only going to do it on the forward sweep. So it should go fast in one direction and slow in another. Fast, slow. fast, slow. Another thing you can do is change the number of degrees that it changes each time. So currently it's moving 1 degree every 5 seconds. I'm going to see what this thing can do by having it move 10 degrees every 5 milliseconds. I keep saying seconds. You can't really tell. You can see the difference. So yeah, this just kind of sucks. So build it for real. All right. So then if you are doing 100% Tinkercad, you would also additionally do another Tinkercad circuit that involves the Arduino. Just pick one out of the gallery and copy it, giving me screenshots of it when it's half done, 3/4 done, and at the end, show me the finished product with the code. So showing. So lots of screenshots if you're doing it in Tinkercad, and only one screenshot required if you're doing it in, actually no screenshots required if you're doing it for real. You can give me the evidence that you modified the code in the video, where an example will follow in just a sec. Hi, Smitty here. I wanted to show off my servo motor running the knob sketch. When I turn my potentiometer, the knob, the servo motor moves along with it. And if you'll give me a moment, I will upload my sweep code that's modified. And so what it's doing is I only modified the first part of the loop. I made it move every 30 degrees. So it's doing the 180 in 30-degree increments. I also delayed it considerably so that you could see its choppy motion, because without the delay, it was really hard to see.